The way I see this panel, it's the who requires, how it's done in the area of AI, ML, the requirements guru here. And by the way, I'm going to push this because he's a Border Patrol agent, but he is actually doing what he does for the entirety of CBP, some of which was just covered a few minutes ago, includes the requirements analysis that he does in his area. And of course, Jay, from industry, representing all of you as to how that might be done in order to incorporate into the operations. So we had a little prep session a day before yesterday. There was almost way too much stuff to talk about. But let's begin with one of the things that I think is critically important here. It is what is known as the accuracy and validity potential of AI and ML. We're in the beginning stages, but it's moving very rapidly. It's evolving very rapidly, giving us a tremendous amount of capabilities, and therefore a very powerful tool. So let me begin with the DAC here. DAC, what do you see as some of the challenges coming forth on the concern of accuracy and reliability as we move forward on AI and ML implementation?
So great question. I think the real challenge is going to be with data. How do we collect it? What does it mean? How does it fit? One of the things that we always, have a challenge with is how do we link data? How do we ensure that it's reliable? How do we ensure that it's accurate? And you'll see that, in terms of what CBP is doing, we've hired a chief data officer to start, helping us get our arms and minds around the challenge of data. Where is that data processed? Is it processed on the edge? Is that data moved and processed somewhere in a back-end system? And making sure that any changes to that data are actually changed that change exists under some governance. And because it's really critical. Without accuracy and data integrity, all things fall apart long term.
So governance, integrity, and utility, bringing value to the operator.
Yes, sir. Absolutely.
So, and those are all great points. Now to you, Josh. We always think of ourselves as an organization that is going to use the capabilities, and that's absolutely correct. But the bigger the pool of players, the more powerful, especially AI and ML, is going to become.
Sure.
So that, to me, translates into interagency, international, binational, trinational, multinational. So, some of those challenges, because of the differences in privacy, interest, sensitivities, come into play. How can we start taking a look at that moving forth?
I think when you get as many players like that involved with something like this, with all the, I don't want to say competing interests, because I think everybody has the same general interest in solving this. I think it gets down to being able to collaborate, and you use that term, and you hear that term a lot, but I think there's something that everybody is now starting to functionally understand, is that there's a bit of a collaboration tax that exists on you when you do something like that. Collaboration is actually slow and expensive. So being able to do it and be able to facilitate those things right is an art, and it takes a kind of a specific person to do that. But I was listening to some of the other speakers that were talking before this, and one of the things they mentioned were the requirements. We talk about requirements, operational, functional, technical, being able to document those things, or going off the objectives. But one of the other speakers had mentioned this discussion of a standard. And one of the things that we've started to experiment with in CBP is using an actual ISO standard, 21838 for anybody that's ISO standard kind of nerdish out here. It's basic formal ontology. It's applied ontology. And essentially what it does is it applies context to the machines. So lexicons, people say you need a lexicon. Lexicons are for human beings. That helps us understand words and definitions. Lexicons do not help the computers. Using something like that ISO standard to define the words that we care about is going to help the machine understand what it is we're talking about, helps translate our reality as human beings into the machine. Using a standard like that is one method. I'm not saying it's the method, But that's one method for achieving this this interagency collaboration. If we can get everybody to agree on what a standard way to go about doing this is, it makes the collaboration that much faster, that much easier, and I think that much more efficient and cost effective.
Okay. Jay, standards. What part does industry play, should play, or can play? Earlier, we talked about understanding the requirements of the operators. So what's industry's part in standardizing to the degree possible?
So I think it's, earlier Josh and I were talking, and it's really about understanding the operator requirements, right? Really understanding what's your mission, because they differ from division to division. And that's, you know, for CBP or any of the services, there's going to be different challenges and different problems. There's some underlying similarities in just how we move data, how we tag data, how we define data, but very specific nuances to each particular division. And it's important that industry understands those needs and doesn't come, you know, try a one-size-fit-all capability. I want to go back to the data standards for a minute, because I think there's two ways to handle this. This is something that across all of our services, DoD, the IC, DHS, everyone's struggling with. How do we get a common taxonomy or ontology? And this goes back to also what Dr. Mays was saying. If we're collecting on the edge and we're dealing with heterogeneous data and it's all disparate and there's multiple sensors and multiple systems, how do we make sure that the computers understand that if 3 different sensors in a particular area are picking up something, that it's standardized so that you can come back and the machines understand that those are all interrelated events, right? So I think part of industry is understanding the mission. The other part is working collaboratively across academia, the government, and the operations to come up with those standards to then inform the machines on how to make better decisions.
Inform machines. Boy, that's, I just got a picture in my head of a Terminator. Inform the machines. So informing the machines, the variances of machines and capabilities, scalability that we have now because of legacy systems and because of the evolution of IT systems, also machines and so forth. How do we look at integration with existing systems, legacy systems, and especially evolving systems that last week we were a week and a half ago we talked about Moore's law and Wong's law, which has reduced timeframes of IT evolution from 18 months to literally 4 to 5, 6 months at a time. So legacy, existing, and evolving IT capability, the integration process.
Well, I think that's a huge challenge, first of all. And if it was easy, right, everyone would do it, right, and they would do it well. And obviously, look around, especially across all the services, the whole of government. It's a challenge. But what I will tell you, and I'd like to just take a second and look back at what Jay had mentioned earlier, was that whole machine-to-machine sort of intercommunication. We have those challenges now. Right, we actually have, non-human interchanges with machines, and we use certificates, right? And you'll see it's one of the key building blocks of zero trust. So those sorts of integrations are hard. And I will also tell you one of the things that, with respect to that, is, I also kind of initiated a lot of the cloud work inside of CBP. When people hear cloud and they hear this sort of work, they hear magic, right? I tell everyone it's solid engineering, it's solid work, and it's one of those things where it takes a lot of creativity and collaboration. And so those are the things across systems that have to happen. Now, everyone all understands, you got to have a common architecture, you got to have a common understanding of data, but you also, no matter what happens with AI and things, you also have to have really good people that understand what they're supporting, how they're supporting it, and why delivery is important. And I think those are the key takeaways for me. Knowing what you're doing, knowing what that end state is, and then building that roadmap to get there.
And if I could just add on to it, I think Dak Mays is right on. Any solution set that industry comes up with. One of the things that I'm generally interested as the requirements person is, how does this trace back to the problem set of the challenge that exists in the field? And one of the things I really want to just sort of push out there right now is, if you have a solution, AI, this deity-like AI that exists out there, whatever that means.
Also, people think magic.
Yeah, yeah, that's right. It's, what is it? Technology indistinguishable from it? I don't know. But what I would encourage folks in industry to do is to not come at the organization with a solution and tell me it's going to solve world hunger, but come at it with the solution in your back pocket. Talk to me about problem sets. Talk to me about the challenges that the operators face, because they're different between the ports of entry. They're different at the ports of entry. They're different for the pilots. They're different in the trade space. But CBP is always willing to talk about this. The problem that ends up happening, just because we've been conditioned this way, is that the solutions come at us and we have to make decisions as to what problems they fix. And sometimes that's square peg, round hole. And I found some people with some big sledgehammers that are willing to put it through that round hole. But that's not the easy way to do it. It's not the efficient way to do it. It's not the cost-effective way to do it. Having industry understand what it is we face as operators in the field, but not even just the operators. There's a mission support side of this whole thing. There's budget, finance, there's the acquisition process, the requirements process. There's a big strategic planning process that backs up the things that we buy, so we can show the American taxpayer you're getting the level of security that you're paying for. Mm-hmm. And it works. And here's how we know. All of that can be backed up and done by these things. But again, just the big point is piggybacking on what Dag Mays was saying. Please talk to the organization about problems and challenges. I encourage you to do that, because the demand signal that will come out of us is going to be truthful, because it's going to be beneficial to the guys and gals that are out there in the field.
Yeah, and I'll add that this whole, it's a real big problem, right? It's a challenge, legacy, current, and future architectures. And I think that we need to start moving towards modular open systems architectures, open standards. In the past, we built technologies or we built applications, which was great. They do really highly functional, high fidelity things. But the problem is you had, you came at it with, I need to build a software that does a certain thing. And that software requires a database where data is in a certain format. And that requires some type of a service layer and some piece of hardware, and then a place that someone can come and interact with. And we see these systems all over, but they don't communicate with each other. So that's the legacy side, and sometimes the current side. So it's, how do we sort of turn that on its head, flip that paradigm, and instead of focusing on, I call them single applications or single software stacks, how do we move towards a modular open system or a single software experience? So what do I mean by that? The operators themselves see it as a single experience, and they're interacting with the machines, and it doesn't feel like they're jumping from system to system or screen to screen. But instead, what's behind that, what powers that, is essentially a common data layer, right, where all of the heterogeneous data can move into as necessary, promoting fabrics and meshes depending on how you want to architect it. A common analytic framework that does the transformations, it does the normalization. So another way to look at the ontologies, if you jump back for a second, is it's very hard to get everybody to the same standard, to call something a particular something, right, or define it. And so you could use a top-down approach where machine learning can actually do that normalization for you. But if we can get to a point where we have that common data layer, we have a common analytic framework, and then we can use some type of, use that analytic framework like a chassis, and now I can put lots of applications in microservices across it. So the operator themselves sees this integrated system, but they're actually accessing different things. And by separating the software from the data, which is the big key here, now we get extensibility. We can talk about the future. I can pull old applications out and bolt new applications in without breaking all of the pipelines beneath it. So you get this interoperability.
So something that kind of ties into what you just said, Jay. Earlier, we had a couple of panels that talked about denied areas, contested areas, degraded areas of communication. So some of the things that we hear about are, for example, secure private networks, operating independently out there in Big Bend, for example. And then the data center up here in Ashburn, quickly moving to the cloud. Integrating all three of those, because that's what it would take for an operator to be operating in the Big Bend or the Boot Hill or Northern Border somewhere, to have the capability to, by way of a secure private network, have the capability to operate and utilize AI or machine learning independent of the cloud, independent of the data center, but when required, backhaul what needs to be backhauled in order to get the universal benefit. How is industry going to address those?
So I think that it's a very good question. I think industry needs to start thinking about, we're all doing big machine learning, right? We're starting to really, deal with heavyweight models that do things like, facial comparison or large language models that we always talk about, or some type of object tracking. And to a degree, because storage and compute are commoditized in the cloud, or because we can have these big data centers, it seems like actually running inference on these, are easy. But the problem is at the edge, we have to assume that we're going to have no connectivity or very little connectivity. We're going to have a thin line, essentially. And so what we need to start thinking about in industry is how do we take these really high fidelity models and how do we take them to the edge rather than bringing the data back? So that means having to start thinking about things like size, weight, and power constraints. How do we do lightweight deployment of these models that doesn't take a lot of computing power, so that what we're transferring back is very small amounts of data? So the way I look at it, because it's easy to visualize, is if you have a drone that is doing video coverage of an area, even in a perfect network environment, you don't want to be backhauling the amount of data for a live video feed to go get it processed inside an operations center. What instead you should be able to do is on that platform or on sensors near that platform or on a forward operating area near that platform, you should be able to run the machine learning inference and say, in this 5-second period or in these 3 frames or whatever it is, I've identified what you're looking for and send only that information back. And if you think about having to do that in a large scale over, hundreds of miles or different areas of operation, then you have to start thinking, because again, if you're on a denied or degraded network, about prioritization and criticality. So that's something else machine learning can do. So not only identify a particular object, but you might have 100 objects being identified in multiple places. How do you prioritize what's most important for backhauling those small messages? So I think industry really needs to look at these edge architectures and look at how we not only do the inference at the edge, but also how we get the right information at the right time back to the operators.
So if I can interject, and I like to say that we need to have better conversations with industry. We, in our CTO office with our CTO, Sunil Madagari, and some of his team that are here in the room, last year we did something that we call the Douglas Analytics Project, right? Now, it was kind of nascent at best, but it taught us a whole lot, and I think we've got an edge computing paper that's coming out or that's already out, and a data paper. But a lot of that we learned along the way, right? And we would have loved to have a little more advice. I mean, we actually did, looking at sensors, processing at the lowest, at nearest to that, where the data was collected, all the way to pushing data back to a big back end, major CSP, and using their AI tools. But we definitely need help. And I look around the room and I think that's one of those things, we'd love to hear from you about your ideas of how we could do it better. Sometimes we come at things, I know I do, from an academic perspective, but there's lessons learned that industry has garnered from all your interactions with all your customer base from around, the country and internationally. We'd like to leverage some of that to make ourselves better, quicker.
Chief, if I could just jump in. So I want to just provide some operational context for this. When you have an agent in the field or an officer at the port or a pilot in the air, they're going through a very quick cycle. So this is just as you develop these solutions or you think about these solutions, think about the cycle that they go through. The initial part of this is they detect a threat. They either see it or something alerts them that something is there. The next step is they identify it. By identify, they say, is it a car? Is it a person? Is it a bird? What is the thing that's out there? And then there's a classification aspect of this thing. How threatening is this item of interest? Then it gets into what we call a track mode. Track is nothing more than redetection over and over and over and over and over again. And when an agent deploys to a detected threat, he's cycling through that constantly. He's wanting to get updates and these things start to update themselves, and they start to get a little more fidelity, and it makes determinations as to how he or she responds. Because going after a 58-year-old grandmother with a 2-year-old child in their arm is different than 7 backpackers with AK-47s strapped to them. You're going to change the way you do business based on what it is you've identified and how you've classified those threats. So when you think about edge computing, let's not forget the machine reasoning side of this thing. If I can turn this into my partner instead of simply a tool, some way, somehow, if I can get this to partner with me, no different than another human or my dog or my horse, that's going to win it for these guys and gals out in the field. That's really one of just putting it out there so you get an understanding of what agents and officers and pilots, even folks in trade, even an IPR violation is still a detection, identification, classification, and a track. Where's this thing in space and time? And knowing where that thing is, up to the minute, being say updated 1,000 times a second, that's what's going to make us that much better. This idea of what I refer to as human-machine teaming. And I'm not building Skynet, Chief, I promise you. So no worries.
I think that's great. So human-machine teaming is a huge passion with what we're trying to do, and I think you're absolutely right. That contextual reasoning piece is so helpful to help the operator because they might be dealing with not just one thing, but multiple things. And they need to understand, again, how to prioritize what they're going to do, how they're going to spread the limited resources across to complete the mission. And I really think what it does is twofold. I think what the machines do, if we can build this, utopia human-machine teaming, it's not about replacing operators or analysts or anyone. It's about augmenting, right, their workflows. So it's about reducing their cognitive load and what they're having to take in and do the reasoning on themselves. And it's also about speed to decision, right, as well as force multiplication, because one operator can do significantly more when a machine is doing what machines do best, which is looking for anomalies, following tracks, finding a signal in the noise, whatever it might be. They tip and cue, and now the operator can act accordingly.
Yeah, we certainly don't want the machines making decisions for us.
Don't want them making decisions.
But I would venture. I would just say this, Chief. Like when we talk about a partnership between humans and making this, a partner, I think the simplest way I've found to put it, and somebody is going to correct me this afternoon, I guarantee it. But humans have an OODA loop. You observe, you orient, you decide, and you act. When we talk about machine teaming, I don't want my machines deciding things for me. I want them to have a modified OODA loop where they observe, orient, trigger, and then act to tell me something that I need to know that I wouldn't have known before.
Yeah. So as I'm listening to this, it all makes sense. Human-machine teaming, speed to decision, tip and cue. So, and you mentioned OODA loop. Observe, orient, decide, and act. That's what we all do.
Absolutely.
But whether it's an OFO officer, a Border Patrol agent, Air and Marine officer, a law enforcement officer, nothing is ever the same. So things are going to change. So beginning with the OODA loop concern, concern, to bring the greatest, most effective, and speediest situational awareness to that human actor so that they can respond appropriately. And then respond appropriately, and once responding, allow RPA, if needed, to engage also, and then the handoff. So that kind of the decision and handoff process, can that be actually accomplished?
So I think the answer is yes. And by the way, I don't think the OODA loop, is just for this, right? Or these processes. I think every human being does it every day of their lives, right? We observe a situation, we pull out the context that's important to us, we do a risk assessment, right? We decide on what we're going to do and how we're going to address it, and then we take some action and have a feedback loop with that, right? I think that's the most human of things. So as we talk about this, I think we're really talking about how do we make things better for those officers and agents, i.e. humans, right, that are out accomplishing a mission. So absolutely. When I look at, and I mentioned the Douglas Analytics Project, it was just a small thing that we did with the CTO shop, but it grew and and now it's pretty important to USBP and the PMOD office, right? Because they're actually doing a small implementation. But what came out of that is we found that we could, collect data, information, have it trigger events, right? Have the important data go up, be looked at by humans, right? And then have that information sent out, if you will, to those officers and agents who actually need it. Not flooding them with a whole lot of data, flooding them with the right data, right? The right amounts of data so that they can actually make decisions. That became pretty important. Did we complete everything that we wanted to do in that POC? No, but we had a lot of lessons learned. And those lessons learned imply to me that this is definitely doable and doable in the near term.
Yeah, I'll just add, I'm just sort of foot stomp something that you said. Being able to make decisions doesn't mean having a lot of data. It means having the right data or the relevant data. So there's, as we continue to add more sensors and add more meshes and networks, and we've got platforms in the air and we've got all sorts of things, all we're going to do is throw a deluge of data at the operators. And of course, that can be overwhelming. So to me, I sort of equate it to, if we understand that we have to get the right data to them at the right time, it becomes a concept like, I use the term, someone probably will correct me, but I call it a data kill chain, right? So we have to ingest the data off the sensor, we have to index it, we have to transform it, we have to condition it, we have to analyze and make sense of it, and then we have to disseminate that out to an operator. And we have to do that very, very quickly. And we might have to do it hundreds of times or thousands of times in very short periods of time. And that's where the machine learning piece can really play. That's where AI plays the role. And that ability to sift through all the noise and deliver only the right data is so important.
Yeah, when we think about right data, Chief, I think what we really need, when this just sort of boils down to the brass tacks right now, we need answers at the speed of the mission. That's what we need in the field. Even a dot on a map telling me a location of something answers the question, where is he? Where is it? I just tell you a quick story. I went on one of these, one of the major public search engines, and I typed in how tall is Mount Everest, and it replied back 29,032 feet. It didn't give me a 75,000 line Excel spreadsheet and told me, hey, good luck figuring this out. I went on to another less popular website and I asked the same question, and it said 29,031.7 feet, which is close enough, right? I went into a CBP system one day and I typed in how many people crossed the border yesterday, which you would assume like our databases have the answer to. I got back the correspondence manual that taught me how to write memorandums. This might be a search out, this is an exaggeration. It's just really more of a sort of a vignette type thing, because that's probably a different problem. But I want to just sort of come back to what she was talking about. It was this idea of the machines being able to process that sort of data kill chain that you talked about in real time. So an operator has an answer to his question about where is it and what is the fastest route for me to get to it? What is it identified as? What's the relative threat level of that thing, whatever that thing happens to be? That's the bridge between, I think Elon Musk has said we're all cyborgs. It's just the bandwidth problem, because we carry our phones. We have the information of the universe in our hands, but we can't process it fast enough. But being able to do it, to put it into the human machine team is really where we're going to make the money. Thank you, sir.
Amazing stuff. So what I heard was it's about the data, it's about the data flow, it is about the assessment and analytics of the assessment, still requiring at this point in time a human interaction to check that assessment and analysis. Absolutely. Selecting the information and data to communicate to the actors, the operators, whoever that's going to be, and then carry forth, go, no go, basically. So recognizing that a lot of those steps right there, and I know I missed probably 10 others in between there, but recognizing the way we're talking about doing this now, you held up your iPhone here a second ago, the endpoints, there has to be a front haul capability, there has to be a back haul capability, there has to be a ZTA and beyond capability. And if you're doing this in the areas where CBP operates, degraded, contested, or denied environments, that means that it's either going to backhaul through satellite, fiber, Wi-Fi, some kind of backhaul. How many security features do we need to overcome to get that data to that end player who's going to go or no go?
So I think there's some good news here. I think that the work that we do with our systems already put a lot of security in place. And I think it's interesting that, and I keep hearkening back to this Douglas Analytics project. We started a project that literally was about, how do I backhaul some data, right, using low Earth orbit satellite. And then we realized, oh, this is a much bigger problem that we were trying to solve, but we couldn't touch all of it. So we touched little, around the periphery, around the edges of it. But what we learned was that, a lot of the things that we were already putting in place for zero trust kind of answers a lot of that cybersecurity, those cybersecurity challenges that are out there. So I don't think there's a whole lot of cyber challenge from that perspective, but I will tell you that not today, but the future, there will be additional challenges, right? One of the projects that we are, Sunil Madagari and his team and I have been working on is something called post-quantum cryptography. And I think that is as Q-Day comes, where quantum computers really come to their own, and people thinking in the audience probably, oh, that's like Skynet and it's way in the future. I think that future is a lot closer than we might think. But that's a bigger challenge, and we're already starting to address that. But in the near term, I think the things that we have in place on our network, in our systems, those systems getting ATO'd, we take a lot of those things into consideration before you get on the network. The other thing that we're doing right now to address that is looking at what's called operational technology, not operational technology as normally described in industry documents where you're looking at control systems for, let's say, power plants or water plants or something like that, but actually looking at, how our systems via IoT or other, actually, whatever those are, whether they are wearables or drones or you name the device, submitting data, how do we make sure that that is secure? So we're putting a lot of thought into this. We just hired an incredible, talented young lady. Her name's Shilu Patel, and she's going to be leading up that organization for us. I mean, we've been interacting with USBP, PMOD. We had a meeting with AMO yesterday, or the day before, and it's just, we're starting to see, how do we do these things? For instance, how do we ensure that whatever that device is on the periphery, that's operational technology, that it's actually, the cyber hygiene is up to date, right? Who's doing that now? I don't know in some cases, right? In some cases I do, but if we get those challenges under our belt and get those fixed and controlled, I think that we're a long way down the road in handling any cyber challenge that may come up.
So now, Dak, one quick question on that, because I've heard that zero trust architecture is basically a baseline right now. It's a threshold that has to be met. But in addition to that, we know that threats are constantly evolving. Mm-hmm. One of the things that a friend of mine has talked about is the use of AI and machine learning to detect anomalous activity that might point to threats that we don't know.
Yes.
How, does that come into play?
It does. Absolutely. Absolutely. And think of this. We've actually been doing those kinds of things for a while now. When you start to look at insider threat, what are those tools doing? They're looking for anomalous behavior. Did Ed Mays log onto his system at 02 in the morning and he doesn't usually do that? Or, from the academic perspective, were we hiding? Did I find something hiding in a file that shouldn't be there, right? And you can see, or a picture, or whatever it happens to be. We see that a lot. So I think these things, from a zero trust perspective, we have gone a long way in addressing, and there will be new and future challenges, right? But I think that, AI will play a big role in observing and looking at some of those. Look, I'm a person that when I look at what we've done from a security perspective, I think we've done quite a lot. But I've read some papers where people using, they were looking at, our networks from a game theory perspective. And I was like, oh my gosh, I never thought of that, and that's a weakness, and I need to address it. But I think I tell people that I believe in our country, I believe in our industry, and I think we've got the right people focusing and will keep us focused on keeping those networks and those systems safe.
I just want to add to this zero trust discussion. So as we proliferate sensors out into the environment, and as we're doing more tactical data backhauling and things like that, we really have to understand that zero trust landscape. So first, what does zero trust mean? I'm not a cyber guy, so I had to really dumb it down for myself. And it's moving from trust but verify to never trust, always verify.
Yes.
And what that means is every sensor, every network, every packet of data, every person that's touching the system, every single time we need to make sure that's really who they say they are or really what the data is supposed to be. And as Chief said, that's definitely AI ML can do a lot of that. But I think it's also about the encryption standards that we're using. We have to really think about like sort of a trifecta of encryption, right? So we have to think about encrypting data at rest, which is table stakes, encrypting data in motion, which is table stakes, but also encrypting data in use. So what does that mean? When we go send data back and forth or we run some type of logic or calculation, data has to decrypt before it can run that calculation. So we need to look at not just post-quantum encryption, but other types of encryption to actually protect data in use as well, so that if there is an adversary on the network, that data remains encrypted even while logic or calculations are taking place. The other thing I think we need to look at is at the sensor level. So we have to start thinking, could someone have tampered with our sensor that is already attached to our network that we expect data to be coming back? And adversarial ML is becoming a real thing. So we need to have fidelity and confidence around the data coming back off of the sensor is the data we expect. The sensor hasn't been tampered with. No one is trying to push a model drift or anything like that to try and tamper with the results we're getting. So there's so much around beyond just the zero trust. But when you look at denied and degraded environments and you look at how we operate with sensors and networks, we really have to think about how we encrypt and how we validate the data that's moving through these networks.
Sir, I think, the really good thing is that we are doing a lot of work in our environment, and, from the innovation with our Invent team to working with our chief technology officer in his office. I mean, for me, these challenges are large, but I think we're up for them. And we're, the whole thing on, data at rest or data wherever it happens to be, all important. Right? But these are challenges that didn't just come today. They've been there for years, right? And making sure that we put the right practices in place, getting, those sort of, best practices is really critical. And, I will tell you, the challenge is large. I mean, there's 100 million attempts a day against the CBP network. That's significant. So, the CTO and I, our DAC for software development, and our CISO, we work hand in hand, and we, collaborate to make sure that we are doing the right things. If you look at our paper that we're going to put out probably in a couple of weeks on post-quantum computing, you'll see that our CISO is hands in there, our CTO is hands in there, and it's because we realize that there's an enemy out there, an adversary that's out there that can harvest now and decrypt later on Q day, right? Which is a challenge. It's a big challenge for us. It's also a big challenge for DoD. But we're trying to put the right things in place to be ready to take on that challenge.
There you go. So Dak, you had mentioned a program, Avatar, I believe you had mentioned?
Yes.
An Avatar program?
Yes. Yes.
Can you give us a little bit of a sense of that?
So we, my organization, along with the CTO, we're definitely working on an AI, an avatar that we're going to get a demo on in the very near future. That's going to, I think it's game-changing technology. That's going to do that brings a whole lot of capability immediately to the table. And a part of that could be, at a port of entry, engaging with, people speaking that have whatever the language might be, and, helping those people solve their problems. They could also be sitting inside of a large compendium of data from CBP, whether it's trade or something else. And I think you mentioned earlier, Josh, that, you looked up something and you got a really oddball answer, right? But this avatar would be able to actually look across our data, not this model will look across our data versus the external world data, right? And pull in answers that are actually valuable and reliable for us. Whether it's, you want to ship, 5 tons of tuna from point A to point B, how do you interact and get that information, get the forms? There's a possibility here for us to become much more efficient and much more effective. And, also, whether it's targeting, tracking bad guys, that sort of thing, these sorts of tools are very, very near to fruition. I think they're coming. And I'm really excited about being here at CBP and being a part of this change, and mostly, being a part of the defense of our nation.
So we're coming up on the end here. Any questions from the audience? And while we're looking for that, I'm going to pose a question for you all to think about. Structured data, unstructured data, open source, all critically important. How hard is it going to be to make sure that we meld all of those to get the outcome that we're looking for? From an assessment, analysis, and go, no-go decision maker.
So I guess I'll take that. Okay, so structured and unstructured data is going to be really important to be able to access, and most open source, so PAI or open source intelligence or commercially available data out there is very often going to be unstructured. I think something like out there is like 85% of all of our data out there is unstructured. So the difference between that means structured data is things that you would think of like, tabular data or something in like an Excel spreadsheet. Unstructured data are your PDFs, your PowerPoints, your SharePoints, your video, your audio, your pictures, all of that. So when we talk about open source, a lot of open source is social media. And so we need to be able to build analytical databases and systems that can pull in all of the data, irrespective of whether it's structured, unstructured, or semi-structured. Should not matter what data format it's in. And it should also be schema agnostic. So what we mean by that is in the past, you've had to sort of build the house before you bring everything inside. But now we don't know what we don't know. So if we assume that every bad guy is only going to have one phone number and we build our databases to hold one phone number, then the other 30 are falling on the floor, right? So it's really about making sure we can process all of the data in any type with, again, schema agnostic, but then leveraging that open source intelligence or that PAI or that commercial data to help verify and validate or make decisions.
And at some point, attempting to make it machine readable too. It's got to be. 2020, the report on CBP was we were sitting on 17 petabytes of data, which just for an example, if that was a book, it would take you almost 30 million years to read. You could have an army of analysts trying to analyze what it is we have in just the CBP trough, and you wouldn't get through it. They could be the size of California, and you wouldn't get through it. It's not going to be until we can make the words make sense to the machines, that the machines can help us troll through all of that, observe, orient itself around it, and then let us know when something important comes up. Currently, I don't see another way around it. That's the problem that we face, is the data sizes just are increasing either geometrically or exponentially. They're just getting larger and larger, and the humans cannot keep up at this point. So how does industry help the government come in to take a look at the issues, the problem sets, the challenges? Let's spend 55 minutes on that. Solution, take 5. Easy money.
Anything you would add to that?
So I think it's a big challenge, but again, I think we're heading in the right direction. I know that, we're looking at, how do we have distributed data across many, I'll call them endpoints, and then being able to pull that data in when it's required and when it's needed, right? I think the CTO's office, again, is working on some mesh networks and that sort of thing. So I think these are old problems, but we now have new solutions and new tools, and especially AI and ML that will help us get to the right answer faster. So I think we're in a really good place. I'm hoping that everybody here in the audience is incredibly optimistic about where we're going, because in my mind's eye, I grew, well, I'm an old guy, but I grew up in a time when I was building neural networks, the old-fashioned way, and it was painful. Now they're out of the box, right? This is cool stuff, and it's great, and it's useful. The utility and the change it's going to drive, the capability for our officers and agents is there, and it's a great time to be a part of this.
Right. Well, great time to be a part of it. Great panel. Thank you very much for all of you participating.
Thank you.
Appreciate it.
Appreciate it.